Pressurized water reactors. Light water reactors, that is LWR. Reactor types using light water as a neutron energy moderator and heat transfer medium together with slightly enriched uranium fuel have become the dominant technology. There are two types of light water reactors: pressurized water and boiling water reactors. Here we are explaining the difference between PWR and BWR, that is pressurized water reactors. PWRs prohibit boiling in the core and use secondary heat exchangers or steam generators to produce steam, which powers the turbine generator. Boiling water reactors. BWRs produce steam directly in the reactor core and pass the steam to the turbine generator. Request: it is hoped that this session is going to be useful to you. Please press like. Please subscribe. Pressurized water reactors, that is PWR. Figure in next slide shows a simplified schematic of PWR. Light water acting as the coolant and moderator passes through the reactor core under high pressure, that is 2250 psi, and removes the fission heat from the uranium fuel. This is the schematic for a pressurized water reactor. Schematic for a pressurized water reactor. Reactor coolant pumps move the water from the reactor to a primary heat exchanger or steam generator, and while passing through the primary side of the steam generator, the reactor coolant gives up the fission heat energy to water on the secondary side, producing steam at saturated condition of 1100 psi at 556 degree Fahrenheit. Here we are having the reactor coolant pump, and this is the steam generator acting as primary heat exchanger. Here we are having the turbine and generator and condenser. The steam expands through a turbine coupled to an electrical generator and then is condensed back to liquid in the condenser. Here we are having the feed water heaters. The water is then returned to the steam generator after preheating in several stages of feed water heaters using turbine extraction steam. This is the reactor core. The reactor core consists of a large number of fuel rods housed in fuel assemblies located in a nearly cylindrical arrangement. A fuel assembly contains a square array of fuel rods up to 17 into 17 or 289 fuel rods. These are the control rods. Each fuel rod is a zirconium alloy clad tube containing pellets of slightly enriched uranium dioxide stacked end to end inside the tube to a height of 12 feet. The reactor is controlled by the use of control rods. The control rods enter from the top of the reactor and pass through the fuel assemblies. Each control rod is a stainless steel tube containing a neutron-absorbing material such as boron carbide or an alloy of silver, indium and cadmium. The reactor core is housed inside a large cylindrical pressure vessel that is designed to withstand the high reactor coolant pressures. The pressure vessel is made of steel with a typical thickness of 6.5 to 7.5 inch, a height of 45 feet and a diameter of 15 feet. Pressurized water reactors have 2 to 4 parallel independent steam generation loops consisting of a steam generator and a reactor coolant pump. A pressurizer on one of the loops maintains the reactor water pressure at constant value. Here request. It is hoped that this session was useful to you. Please press like. Please subscribe.